Okay, let's continue. So I'm Elham. I'm a postdoc in Kami's group, and I mainly work with soaring birds and their interaction with the atmospheric environment. And today I'm going to talk about environmental annotations and movement in the context of the environment in general. We will do some plotting mainly because, obtaining the data really depends on what variables you're looking at. So far in the course, we've talked a lot about the geometry of movement tracks and everything, and then also from Ines, we learned about remote sensing and all the environmental products that there are. But I think from this point onwards, we will talk a lot more about actually putting these together. And the importance, you are probably aware of all of these points, that why do we need to look at environment and movement together? So of course, environmental factors influence movement. So the physical environment determines the costs of movement, which is something that Kami's group works on a lot, the concept of the energy landscape, which he covered in his talk. The distribution of resources and predators and many other factors impact decision-making of where to go. And also, adaptations to the environment explain a lot of behavioral and morphological characteristics and the evolution of these in animals. And then there is the feedback between the environment and the movement. So the animals can also impact the environment with their movement. So if an elephant is moving through a landscape, it's going to create these paths that then other species can use. So the elephant is impacting the environment as well. So there are all of these different aspects that could be relevant for your projects that would inspire you to want to look at movement and environmental conditions at the same time. So I work on bird flight, so many of the examples that I will give, or the one example that I will give, is a bird flying in windy conditions. And I just want to give you a little bit of background on why we study wind conditions and flight. So tailwinds, which are winds that blow in the same direction as an animal is flying, are really important in helping them move faster and save energy. And if the wind is blowing from the other direction, it's going to blow in their faces, it kind of hinders them and it slows them down. And wind conditions are really important for birds, for their decision to live somewhere, to breed, and also forage. So it's like decision making at the smaller scale of like on a foraging trip, but also the larger scale, macroecological scale of where birds are distributed. Birds alter their flight behaviors or activity levels in response to changes in wind speed and direction, also at many different scales. And we know now that climate change can also impact wind conditions, and that could influence how birds operate. For example, migration routes could be impacted, or breeding ranges could be not suitable anymore for some species. So when we talk about wind, there are two main components that we look at. So this is also the data that you can download. Like when you download wind data from any meteorological station or a weather database, wind comes in two vectors. So you have the U and the V. So the U is eastward wind, V is northward wind. And we calculate wind speed from this, which is the magnitude of the wind vector, and it's the purple line. And it's kind of the same idea if you work with marine animals and you want to calculate ocean currents, so it's just fluid dynamics, basically. So I have wind speed here, which you will see later in the code, so I'm just introducing it, even if you don't work with birds or winds, just so you know later on what we're talking about. And then, of course, there's wind direction, which shows you where the wind is blowing from, which is how it's defined in meteorology. Or in ecology, sometimes it's where wind is blowing towards. So always check, if you look into the literature on wind direction, how they define it. And as I mentioned earlier, headwind, wind is blowing towards the animal. It creates more energetic costs for flight. But if you have tailwind or wind support, then it helps the animal move faster. So it's good. Crosswind, wind blowing from the side, can blow the animal off of its course. It can impact the heading, as Martina mentioned, because the tag that you have that calculates heading, it will tell you the axis of the bird's body or the animal's body. So if it's shifted by the wind, you still see that it's facing this direction, but it's moving in this direction. So it's the difference between heading and like the angle of movement. And then if we just revisit speed really quickly, so if you have a flying animal or an animal in the ocean that is impacted by currents, then the speed is impacted by what is existing in the movement of the fluid that they're moving through, or the air. So in the case of birds, we calculate ground speed as the vector sum of airspeed and wind speed. So the speed that the animal would have on its own, plus what the air is either like contributing or taking from it. OK, now we go to track annotations. So when we talk about track annotations, we basically have, so from our whatever devices we use to collect movement data, we have this black trajectory with different points in time and space. And track annotation is basically extracting environmental values at each of these points in space and time. If you're working with a terrestrial mammal, for example, then it's mainly probably the 2D time, the 2D space. So it's just latitude and longitude. But if you have a bird or a bat or anything in the air, you might want to look at the 3D space because it's latitude, longitude, but also the altitude. So here I have some examples. So we have, for example, wind speed, temperature, humidity, land cover type that we can extract for each of these points. And some of these variables are more dynamic than others. So for example, if you're looking at land cover type, I mean, of course, it is dynamic to some extent, but the data that you get, maybe you can get it for like once every 10 years or something. So you have a raster layer, and you extract the values from it. But if you have something like wind speed, it changes so quickly, and the data that you obtain can be, for example, for every hour, or if it's a finer scale, could be maybe every half hour, and then you have to annotate it in space and also in time, so to extract the actual condition that the animal experienced at that point in time and space. Very important. Please make sure that the resolution of your environmental data and movement data match to some extent. So this is just an example that I put here. So it's a wind layer. So the arrows show you wind conditions. And these are the cell sizes that you have. And if this is the tracking data that you had with really high resolution tracking, the environmental data cannot help you too much because for all of these different points, you're going to get the same value. So in a case like this, which happens a lot because now we can collect a lot of tracking data, but the environmental data is still at a coarse resolution for most of us. So in a case like this, you might want to consider just subsampling your movement data to have one point that falls over each of these cells. Or, I mean, you will need to do it based on your specific question and your data, but always make sure that the resolution of the tracking data and the environmental data make sense together. All right, so sources of environmental data. So we already heard a lot about remote sensing products and how to obtain them and how to work with them. But one thing that we use a lot, or used to use a lot at the Institute, is the ENV data service on MoveBank. So this is a really cool service provided by MoveBank where you can annotate your data, or you can just request annotation of your data. And it's really awesome because, or it could be. I'll tell you why it might not be anymore. I'll just show you very briefly. So if you go to MoveBank and you log in, OK. So I will, for example, go to just one random study, and then you see the ENV data tab up here. So here you can say start annotation request. And then it gives you a few options. So you can either annotate the tracking data from the study that you already have opened, or you can upload a generic time location file, which is a CSV file that you want data for, or a gridded area. So the gridded area is basically you determine the extent of the area of your study, and then you ask for certain variables within that. So it returns raster data. All of these are really well documented. So make sure to look at the user manual if you want to use any of these, because there are limitations on how much data you can request. So for example, I never use gridded data because I work with migratory birds that fly from Northern Europe to Southern Africa. And the area that MoveBank allows you to request is just so small that it doesn't make sense for me. So I prefer to directly download my data from ECMWF or other sources. But the one that I personally use a lot is the generic time location record, because here I can decide which points I need environmental data for. This first one, requesting data for the tracking for the study, this can get out of control really quickly because some studies are just so big that you can't, that it might take forever for the request to be done, or you will hit the walls on like the limit on the number of rows of data that you can request. So this one gives you the most amount of control, so the generic time location. And what this requires is a CSV file with these column names. So timestamp, location, lat, long, height above meters, height above sea level, which is optional. But make sure if you decide to do this to name your columns exactly as is stated here, and with these formats. So it needs to have milliseconds, for example. So I'm going to just open one file that I already have here. But yeah, so you can just browse to a certain file, and then when you click continue, the file will be loaded, and you will be presented with this list of all sorts of environmental variables. So there is weather data, so ECMWF, that I use a lot. And it's like temperature, precipitation, wind. There is MODIS data, distance to nearest coast, like all of this. There's NDVI. And then everything is, again, well documented. So you can click on the eye, and then it will give you a link to the source. And you can really see what it is that you need. And also, for example, with ECMWF, if you just look at the documentation, it tells you the definition, the units, which is super important, and all of that. So for example, I'll just choose this one just to demonstrate. And then you pick it, you say continue. And then, so recently, for people who care about ECMWF data, which is weather data, so there is a lot of limitations now on how much data you can request. So keep that in mind if you need to download or request track annotation for atmospheric data, and adjust your requests accordingly. So you might need to break up your requests into many, many different files and then upload them. Otherwise, if the request is more than what you're allowed, then you'll just get a message that says the request failed. But as I said, OK, let's just continue with this. So let's say that I have made sure that my file size and everything follows the requirements, and then I send my annotation request. Then you can see the request that you have made, and then once the request is done, you will get an email notification. You can come back to MoveBank and download the annotated file. This can be very fast, depending on the variables that you're requesting. But I would say if you request something, it doesn't fail within a week, and it doesn't give you back the data, email the MoveBank support team. It shouldn't take more than a week or two, from my experience. And as I mentioned, the documentation is very complete.
So the things that you can annotate or the datasets, does it only includes global datasets or also some maybe regional ones like, let's say, land cover and land use from the US or things like that?
I think it's mostly global, but so the products are mentioned and listed in the documentation. So, I mean, this is just a tutorial, but
Yes.
yeah. So environmental data products. So you can see the spatial and the temporal extent.
So given that data can be anywhere in the world, the one thing that is limiting is just that the environmentals that are available have to cover the entire world.
Okay.
So you can't have the regional ones, or you can.
But there is for the US, for
Yeah.
the weather model for the US.
Ah, okay. So they changed that.
So not little regions, but yeah.
Okay.
Yeah, I don't know.
So the whole of continents might be available for certain areas. Okay.
Yeah.
That was different some time ago, but maybe they updated that.
Sorry, the annotation will be then given as a CS file. It will also be stored on MoveBank with my data.
So
Or if I ask them again, I have to annotate again.
So it will get deleted once you download
Okay.
the annotated data. It won't stay on the MoveBank server.
You mentioned there's a limitation, a number of rows or file size. Is that due to bandwidth, or is there an element of manual processing that's done by MoveBank, or why is there such a limitation?
So the limits, so for ECMWF, for example, the limit has to do with how much data one is allowed to request from ECMWF. So it's the limitation of this data product that we want to access. But also in general, there is a limit of 1 million rows on the CSV files that you request. And I think it's just because they want to make sure that the resources can be allocated to many users and one user doesn't just take up all the server resources.
And just out of curiosity, how long do you typically wait for an annotated data set to come back to you?
So I have waited between like 5 minutes and months. So it really depends on how many people are requesting data, how you will get queued in all of the requests that are coming. But like, if you request your data on a weekend, like it's faster because not that many people are working. So it's like these things that I've experienced. But I think overall it's not super slow. As I said, if it takes more than a week, get in touch with the support team.
But like that's maybe if you want, makes sense if you want to use several data sets, saves time. But if you are only gonna use like one or two, maybe it's just better to download it, no?
Yeah, so I have this like overall like tips and tricks here. So if you request multiple variables from different data products, that might take a long time and it might fail on you. So request few variables of like the same category and from the same data product in one request.
Okay.
I feel like that's usually a safe thing to do. Any other questions?
So can I comment on your
Yeah.
question? Because you said, oh, then if you only want to annotate from one variable, you just download the file. So maybe if it doesn't have a temporal component, you might want to you can do that. But if you want to annotate temperature over 10 years of tracking data, then it's not just downloading temperature, because you have to download all the layers of all the hours of all the 10 years, and that is kind of you can do that, but maybe it's easier to do it this way.
I guess I was thinking on like.
Do you want to
static?
hand over the,
Yeah, no, that totally makes sense. I was thinking on static variables like line cover or whatever.
Yeah,
things that
for
don't
sure.
change that much. Elevation.
Yeah, I never use env data for land cover or like raster layers that you just, or like topography even. Because you just have the raster layer, you extract the values. But if it's the dynamic variables that make it difficult, because also if you want to annotate in 3D, you have to make sure that you download the data for like the pressure level that matches your data, and it can get a little tricky, depending on your disk space also, because like, are you going to download all of this environmental data so you can annotate your whatever many points? It's a trade-off. We'll talk about it more in the coding section.
And I see the power now.
Yeah. There's one question.
So can we request data for specific dates? For example, if I'm talking about migratory season, so I need data for specifically those 15 days.
Yeah.
So can I get the annotation for the data that is between those 15 days only?
Yeah, so you can get very creative. I would say with the generic time and location format, because like MoveBank doesn't care what you're requesting for what area or for what time period. So you make a CSV file. You just need to have timestamp, location, latitude, and longitude for whatever you need at whatever temporal and spatial resolution that you need. It will just annotate for you for those points.
No, but the data that comes in the annotation. For example,
Yeah.
I need temperature between that, let's say in April only. So do I get that data or I get the generic data?
So you get the data closest to that time and space. Am I
Okay.
not on?
Closest to
the
the my timing, my data timing.
Okay. Are we talking about time zones?
No. For example, my cranes are flying between 15th of April to 30th of April.
Yeah.
I need temperature of this particular region between that
Yeah.
time
Okay.
period only.
Yes.
Yeah.
So you make a CSV file with one row. Okay. So you have the area that you want, right? So you have the latitudes and longitudes, and then you will just copy and paste these latitudes and longitudes for like every day between the two dates that you just mentioned, and you just give each chunk one date. So the 15th of April for the first chunk, and then 16th if you want daily temperature. You see what I mean? So you can adjust it.
Okay. Yeah.
You can just ask. You're like, give me data for this point at this, on this day, at this time. Yeah?
Yeah. Thank you.
Sorry? Yeah, it doesn't have to be real.
Oh.
Yeah. It's just location and time, and then it will just spit back whatever variables you asked for. Yeah, there was a question, I think.
To some extent. It's similar. I just wanted, for example, we did a long following and recording the track of an animal.
Yeah.
And then it would be interesting for us to see in these 24 hours what would be the temperature at each hour. So I can just like choose one central point, because anyway, it's the same temperature.
Yeah.
And then just repeat 24 times with the different hours and request that.
Yeah.
Cool.
Any other questions? No. Okay. Cool. So that's MoveBank, end of data service. So use it. It's really fun. It really makes life easy. But now we will move to the more hands-on part of the session. So the code is called environmental annotation or annotations. I can't remember if it has an S or not. It does. Okay. Yeah. Okay. Is the font size okay? Should I make it bigger?
Where is the script?
The script is in the environmental annotations folder. Yeah. And make sure that the environmental annotation folder is your working directory, because we will pull data from there. And the packages were already included, I think, in the AniMove GitHub thing. So you should have them already installed, so that should be fine. All right, so the data we'll be using today is from a paper that Kami also mentioned in his talk about albatrosses and storms, well, seabirds and storms. So I have also linked the paper and the GitHub repository for the code that was used for that paper in case you're interested or you think it's useful. Okay, so let's start. So I have included a foraging track for one albatross in the albatross track.rds file. It's already thinned to an hourly interval because when I was using this data set, I was using a bunch of different seabird data sets, and I wanted them to have the same resolution, and I wanted it to match the environmental data, so I just thinned everything to hourly. So that's already done here. And Martina covered thinning the data at some point. So if you want to know how to do it, please refer back to that lecture. All right, so this, I'm going to call it Albi for now. This albatross that didn't have a name, and I just gave it this name, just for fun. So it's a data frame now, but just so that I can see where in the world it falls, I'm going to convert it into an SF object. Oops, didn't load my packages. Does everyone have access to the data, and did you all open it?
It's only the map view.
Oh no, it's not view again?
No worries.
Okay.
We can see it here.
All right, we will do more proper plotting with ggplot later on, so don't worry. All right, so yeah, this is what I normally do when I'm just exploring a data set. I use map view because it's just so easy to see where it is, and then it's interactive, so I can click on it. So this is one foraging track, as I mentioned. All right, so now what I want to know is what were the wind conditions like when this albatross was foraging in the ocean? So here I have included a chunk of code that downloads wind data for you. So this is using the ECMWR package. So it allows you to go through the API and download, I would say, weather and climate data. So if you need temperature or if you need precipitation, you can also use this code. So you just need to make sure that you have an account on the Copernicus Climate Data Store, and then you can use this script. I don't recommend running it now because it won't be reproducible if you don't have an account. But I'll just walk you through it in case you need it, you want to use this at some point. So the way it works is that I need to prepare a request, right? So I want to tell the Copernicus Climate Data Store what kind of data I want. So what variables do I want for what period of time and for what locations? So here I'm just extracting a bunch of just temporal information about the data set. So I want to know what year it is, so I just extract the year, and I give it a name, so it's 2014. The months, it's just 1 month in November, and it's 3 days. So it's 3 days in November. And then I'm going to just download the data for every hour during these 3 days. So again, this depends on the resolution of the data you're downloading. If you're downloading monthly data, then of course hour and day might not apply to you. But the data set that I'm interested in is hourly. So I say, OK, for all hours in a day, I just want to have a character string that has all the hours. All right. And then you can also decide on a bounding box, so the geographic extent that you want the data in. But I will determine that later on. And then I'm going to say this is going to be my output path. So I have a folder called wind for Albi, which already exists in the data folder that you guys have. But this is where everything will be saved as it's coming in and it's getting downloaded. So this is where I put in my credentials for the CDS. So I have put a link to a tutorial if you want to know how to set this up. This tutorial is really clear, and you can just follow that. And then I have decided to request one file per hour, because with the way that my brain works and with the way that I'm happy coding, I would prefer to have one file for every hour. So that's what I'm doing here. So I'm going through each day in my data, well, in the days that I want the data for. And then for each hour, I'm creating one request. So the formatting of this is what that tutorial suggests. So you can also follow that later to get more information. But here I say what the name of the data set is that I'm interested in. So it's the reanalysis for ERA 5 at the single level. So it's only at the surface of the Earth level. And then here I have put in the variables that I'm interested in. So in this case, I'm interested in wind. So I have the U and the V components of the wind. And then year, I have this year and month and day and hour that I have determined earlier. And I've also included the area for which I want to download the data. So if you don't put in the area, you can download the whole globe, which is fine if you need it, but you can also limit it. You could also you could also reduce the resolution of the data, the spatial resolution. So this data comes in roughly 30 kilometer by 30 kilometer. And if you wanted, you could reduce that. But I'm going to just download the original resolution. And then here, I'm just sending my request in. So I would need to put in my user ID. And then here I have the request, and then the path where everything will be saved. And one thing to note is that if I wanted to, I could have downloaded all of this in just one request. But again, it's the issue of when you have a big request, then you might be queued for longer when you request this data. But if you have like small requests, then they're done faster because it's not going to take up a lot of resources. So the server will kind of deal with your request sooner. But then if you want to request many requests, then there's, again, a stop sign that will be like, OK, no, you've requested too much. Then you have to wait for a certain amount of time, and then you can request again. But these are things that will really depend on how big of a data set you need. So just be aware of it, inform yourself of the limitations, and then decide on how you want to approach requesting data. But this was super fast. So with this, it's a tiny area, tiny amount of data. This maybe took, like, I don't know, less than 5 minutes for everything to be downloaded.
Sorry, in area? In area, the values are, what are the degrees? When we specify the areas?
Yeah.
OK, they are the degrees. Thank you.
Oh, I thought you wanted to say something. That's why
Say something.
Are you the mic
No,
boy?
I'm waiting for someone to ask a question.
Okay. All right. Cool. OK. Yeah. So then, so now we can look at the data that we actually downloaded. So I'm going to list all the files that are in Wind for Albi. Oops. So now I have one .cdf file per hour for these 3 days that I was interested in. And .cdf files are really cool because they have your data, but also they have the metadata. So if you want to, I mean, here we're going to treat them as raster files.
Oops,
Yeah.
Sorry, maybe. Sorry.
Before you began, I think some of us were having trouble with the zip file, and
Okay.
there's only 5 day files, at least in my version. Is there another way we can download those more reliably?
We put the data on a USB stick. Yeah.
There's a drive.
Yeah, thanks. How many of you don't have all of the data? So we can, okay, so maybe we can put the data on more USB sticks. Can you, because I have a different format now. Thanks. Do we have more USB sticks? There's one over there.
Yeah, Edward is. Edward. USB stick.
Sorry, you became my assistant.
Let's put it on the group.
Thank you. Okay, there's another USB stick with the data. I think it'll take more than an hour. Is that going to be okay?
Jetzt ist hier noch über eine Stunde, 10 Minuten ungefähr. Das sollte ja. Perfekt. Nee, nur manchmal stoppt er, wenn man Programme wechselt.
Okay.
Mal ist es so, mal so nicht, deshalb kommen wir auch so oft nach vorne.
I see. Okay, yeah.
Who else needs a USB?
Cool. Thanks, V.
No.
You guys?
So I have the data, but your files have a semicolon or a colon, and mine, like Windows doesn't allow that. In the
Huh.
and like your code kind of requires that because I tried running it and I hacked away.
Yeah. Interesting.
But then I didn't figure out the whole step. I could like load the raster from that.
I mean, if you replace the colon with just an underscore, yeah.
But then
But then,
the time in the raster.
yeah, you would have to change that too. So in a previous version, I had like the hour without anything after, so it would be like 12, 13. So you could also do that.
Substrate.
Yeah.
Chop off the last
Yeah.
Can we have a
Yeah, but good point.
She just asked me earlier today, and I was like,
Yeah.
The last part of,
No,
this
I'm
of the code,
irregularly
because
in conversation with
I
her.
just entered my user and my APK and it is not working. I don't know why.
Okay, it's because of the
No,
colon.
no.
Yeah, it's the file names.
best way to do
You have Windows, right?
Okay.
Yeah.
You want in terms of
So
what
you see
were
my
gonna do next week.
my file names, they have the colon, so it's
Yeah.
1300, but yours is underscore.
I will.
So
okay.
it doesn't match. So later on,
Just
I'm
also
using
because I'm
this
not
to
sure, you know,
match
everything works. I
the
tried it
data
with
to
one
the
source
file.
for 3 years.
And
I would be
apparently,
interested to see
yeah,
if-
Windows
if-
doesn't
if it was
recognize
run
those.
with another data set.
So that, I think that's the issue.
But just manually downloading all the
Yeah.
CD files, just manually from Verify, you know, not by using.
Yeah, it's just the naming of the files. Okay, does anyone else need the data? No? Okay. All right, so one thing that came to my attention is that Windows apparently doesn't recognize this colon here, and it reads it as underscores. So that's, yeah. So I'll tell you why that's there. So it's because of the way I named my files. So in the request, I said the target file should be named like this. So wind, so I'll be wind, and then the year, month, day, and hour. And then the hour is in the hour format. So that's how I named my files. And I'm running Linux, and it's not an issue. But yeah. So you might not be able to recreate this. This code might not be fully reproducible for you at the moment. But when you run it for yourself later on, make sure to change the way you name the files so that you don't have the colon. But for now, you can just follow what I say if your computers don't run it the way it was intended to. OK. So let's continue. So yeah, so now we have wind data. So for each hour in these 3-day period, we have one wind file. But now we still don't have these environmental data matching the points that we have. So I just have a bunch of wind data and a bunch of tracking points that are separate from each other. So in the next chunk of code, so I'm going to actually do the annotation. So I'm creating a new column here in the albsf file for each unique hour. So then, yeah, I'll just show you. So now I have the unique hour here that matches the names of the files that I have. So that's how I can open the tracking point and the corresponding wind data and then extract the value. So now what I'm doing is that I'm going through using lapply for each unique hour in the track. I open the wind data or the netcdf file as a raster, and then I'm just extracting. So this extract is from the Terra package. So I'm just extracting the U and the V values for that point. All right. And that's the chunk of code that might throw errors for you guys if you're on Windows. Does it work on Mac?
We have to specify Terra package for the extract function on a Mac.
Yeah?
Then it runs for me.
OK. Good to know.
Oh, yeah.
OK, that's perfect. Thank you. So yeah, try this. So specify the Terra package here. Does it also work on Windows? No, no, right? It shouldn't. No, 'cause that's a different issue. Okay.
Specify Terra? Is that before extract?
Before extract. But apparently this solves an issue that Mac users had. Yeah. All right. So now that I have done the annotations, now I have, so if I look at, if I look at the data set now, wait, where is it? No, what did I call it? I called it annotated. OK, so now if I look at the output, now I have my SF object, but also new columns for U and V. So these were the two components of wind. So I can use map view to look at the track again, but this time color it based on either of these variables. So U or V. So I can see that. And then I'm like, OK, well, U and V are the components of the wind, but they don't really tell me anything. Like, I can't interpret it by just looking at it. So I will calculate wind speed. So that's what's happening here. So I calculated the wind speed. This is in meters per second. So if I plot it, then now it kind of makes more sense. So when this albatross was flying, it experienced wind conditions between like 3 to 19 meters per second. Okay, and if you didn't, if you weren't able to run that code, I already saved the Albatross annotated RDS file that you can just load, that you can read using read RDS, and then you can follow the code from there. Right. Okay, so now we matched the environmental data and the tracking data, and we want to do some exploration. So this time I want to, I want to compare the conditions that Albi experienced to the conditions that were available around it. Because, maybe it was making decisions. It was maybe preferring to use certain wind speeds versus others. Maybe it was avoiding certain wind speeds. So for that, I'm going to just convert the netcdf files that I had into one data frame with all of the wind data in it. So that's what this code does, winddf. So it opens all of each of the netcdf files, adds a raster, and then turns it into a data frame, and then binds all of these data frames together to create just one.
I think it's in the file path.
Yeah?
Yeah. It has to be data.
Oh yes, good point. Yeah.
Yeah.
Thank you. All right, okay, so, all right. Yes. Okay, so please note, so there is something missing in the code. So on line 152, you need to specify the folder. So data/wind for Albi. That was missing for me, so it wasn't running. And again, if you have issues running the code, the RDS file for winddf already exists in the data folder.
And sorry, what did you change on the code?
So I hadn't specified the folder here where I'm listing the files for wind. So you need to add the data /. Okay, so now that I have a data frame with all the wind data in it, I can look at the summary just to see the summary of wind speed. So I see that in the Albi annotated file, my maximum wind speed was 19. But if I look at all of the wind data for that region for those days, the maximum wind speed was 23. But if you look at the mean of what Albi used was 13. The mean of what was available was 6. So you can kind of see that this albatross was kind of choosing stronger winds. But for some reason, it didn't encounter the strongest wind, which was 23 meters per second. And then if you want to look at it in more detail, you can just plot some sort of a distribution plot or box plots here that kind of show you the same thing. That what was available had a lower mean, but had a higher max. Okay. So that's something that we will explore more in a bit. But before we get there, I wanted to just include some plotting code for if you want to, like in a paper, you want to color your tracks based on an environmental variable, just how you would go about doing that. So I'm doing that for Albi for wind speed. So I have the world layer for my background, and then I just use ggplot to, wait, where did it go? To plot the world in the extent that I want it, and then I add the track over top, and I decide on a color palette that makes sense with my data, and I just do some cleaning up for the title of the plot and the legend and everything. So here you can see we have wind speed that's colored, and so it gives you a better idea of what wind conditions this bird was experiencing. Any questions so far? You look like you have a question. He looks like he has.
He looks
Yeah.
Thanks. Just out of curiosity, could you add the direction of the wind somehow?
We'll get to that.
Okay.
Yes. I mean, you could also color it based on that. I didn't calculate wind direction, but you could calculate it and then instead of wind speed, have wind direction be the color. But in a bit, we will actually plot the wind fields. All right, so one point, so here what I'm doing is that I create the plot, I save it as WS, so it's an object. And then before plotting it, I open a new device. So apparently in Mac, this would be Quartz instead of X11. And then I plot in that device. So if you have issues, try just running the plotting code without the assignment to WS and see what happens.
Thank you. This is annotating just the speed and not the direction of the wind.
So this is not annotating. This is just plotting. So
Yeah,
I
sorry.
calculated wind speed earlier, and I'm just using it to color the track. I could have calculated wind direction, but I didn't. But you could. Yeah.
So it means if I look at this graph, is that I cannot say in which direction is going the wind, but just the intensity of the wind.
Yes.
Okay.
Yeah, so it's just wind speed in meters per second. No direction here.
Oh, this is mine. I should
All right.
remember to take
Okay,
this.
so now
Where is my backpack?
I want to take advantage of the fact that I downloaded the wind data for a bigger area than just where Albi was flying. So that allows me to look at the whole wind field that it was flying over, and then maybe it will help me understand what was the deal with that 23 meter per second wind. Was it avoiding it? Was it just too far from it? Like, what was happening? So this is another plotting exercise that has a few steps. So again, I need the world as the background. But I'm also preparing the world as a data frame, which you will see why later. And then I have the extent for my plot, which I manually decided on, and I'm setting here, which you can play around with and decide on your own for your data. And then one thing that I'm doing here is that, so the data that I downloaded was at a relatively high resolution for this big area that I need to plot. So if I want to plot all of that wind data, then it will be very messy. So here I'm just doing a quick and dirty trick to reduce the resolution of the wind data. And I'm just rounding up the values of latitude and longitude. Yeah, not the best way, now that I think about it. It would make sense if you know, so like you're like, okay, like the resolution was 30 by 30 kilometers, now I want to reduce it to 100 by 100 or something. But I'm using a code that I had, and that's what I had done. So this will be a new data frame with wind data in it, but it's just a lower resolution. Okay. And then I'm going to open the tracking data, but this time I'm just going to use the data frame. I'm not going to use the SF, because it's just easier to plot like that with ggplot. And I'm creating the unique hour column again. All right, so now we did some prep work. Now we're ready to make one map for 1 hour. So for 1 hour of tracking data, I want to plot the entire wind field and the tracking point on top. So I need to extract the wind for that unique hour, and then I will run this long code. And again, keep in mind that I'm opening a new device, so if you don't want to do that, make sure to skip that line. And this is what I get. So I have colored the entire thing, the ocean, by wind speed. And I have the one tracking point that happened at this hour on top. And then on the top, I specify what hour this happened. OK. So in the next step, to understand what happened at every hour, I'm going to just run an lapply code to create one of these frames for every hour in the tracking data and save a PNG file for each of these. So that's what the next chunk of code will do. Where's my cursor?
There's lots of questions.
Yeah? Yeah, I don't think they can run it.
Sorry, it's
because
just
of
that we get just a point.
We don't get the map of
We don't really get the map.
Do you get? Do you get? So it might be again the problem of matching. Do you get anything in the wind object? Because it could be the matching of the hours again.
Yeah, 0 observations.
You have the whole plot.
Well, the world isn't loading. There's just one line in the ggplot that doesn't work.
Okay. I think, okay, so on Mac it runs. Does it run for you? Linux forever. Okay.
It's the column sign. No?
Yeah, yeah.
Yeah. The column sign.
Yeah, so what I'm doing here, just like before, I'm using the unique hour to match the hour of the tracking data to the name of the file for that hour. And on Windows, these don't match because the hour has a colon in the tracking data, but not in the file name.
In general, in your code, when you do the request for the file name, you can actually just make the file name to avoid having columns or minuses and so on and so forth. So you can still do that. So, because when you do the request using the ECMWFR package, you create the request. There is also an option where you can set the out file equals to, so your request already has a file name. And you can actually make the file name to be indicative of year, date, whatever, or even individual track, and so on and so forth. So you can actually make a file name that will be informative to you, that you can parse once you have the file so that you know which file belongs to which part of your track. So again, whenever you're making files or downloading files from anywhere, try to avoid colons, minuses, and other reserved this and sign, percentage. This is like all bad choices for to appear in any file name. And that can be set in the very beginning of Elham's code for where you make this CDS request, so the Copernicus Data Service request. There you can actually specify the out file. So every request can have a specific out file that will be the file under which CDS will save the data for you.
But then again, you have to think about, so I thought I was being clever because I was like, oh.
We all think that, but then.
Yeah. I mean, it works on my computer.
Yeah.
But yeah, so think about it, like name the file in a way that then it can help you retrieve it when you need it to match it with other things. I don't know.
Yeah, there is people who don't want to find out why it's working. It's just working. That's enough. Good enough. Yeah. Yeah. Just don't touch it.
Wait, okay. One thing I forgot. So did anybody run the inset code? So this was cool. I spent too much of my life on this chunk. So this is just plotting, wait, where is it? Where the track is on the globe. Isn't it nice? Yeah, thank you so much. And then we can put this on the wind field map. So that's cool. So here, this chunk of code with map with inset. So this does that. So now you have, so now even though you're only plotting one point, at least you know what the whole track looked like. Okay. All right, so, and then in the next step, so it's here, from line 327 for me, where I'm just going to go over all the unique hours, create the main map and the inset. No, the inset I already made. So I create the map, and then I add the inset, and I save it as a PNG file. I didn't give you the PNG files because it was too much, but if you want them, I didn't think we wouldn't be able to run them. Yeah. But if you run all of that, I'll show you what it looks like. So you will have, where is it? So you will basically have all of the frames in a folder like this. Wait, the title is wrong. Okay, I spoiled it. All right, so now I have one file per hour, and I just want to click through it to see what was happening. So you can see Albie flying, and then a storm comes, and then Albie goes in the center of the storm, and then flies in the eye of the storm, and then escapes eventually. So, yeah. So this is what comes out in the end. So you have one frame per hour, and then what you can do is that you can create an MP4 file with all of this, depending on, wait, it's running over here. No. So I run a code in Linux to make this. But apparently there are ways in R to do it too. But also there are websites that will allow you to just upload PNG files or images and then create an animation. But yeah, so that was that. So this is the line of code that I use from the Linux terminal to make the animation. Don't worry about it if you don't use FFmpeg. But the conclusion is that Albie flew in the eye of the storm. That's how it avoided the 23 kilometer per hour, well, meters per second winds. And it's really cool because albatrosses usually like wind. That's the end. If you have any questions, yeah. This one.
The bar plot that you showed, can you please explain it again? Sorry, the box plot.
The box plot?
Yeah, the available and the used versus used.
Yeah. Okay. What was it? All right. So I do a lot of comparing what the animal chose with what was available in my research. So you will learn more about it with step selection functions and resource selection functions tomorrow, I think. But one thing that you would normally do to have an understanding of whether the animal even was making a choice is to compare the conditions that it used with what was available around it that it could have used. So the box plot is basically that. So the blue is the wind conditions in the entire area. So all the wind values that I downloaded for the area around Albi. And then the red is only the data from the tracking data frame. So just the annotated data of Albi itself. So these are the points that it used. These are the conditions in the general area. Yeah? You mean the interpretation? All right. So albatrosses really like strong winds, right? So which is what we can see here. Because like, if this was the kind of the median conditions that were available, it did use most of it. Because keep in mind that what the bird used is within what was available. It was in that area, right? So it didn't use like these lower ends. It tried to use the stronger winds that were available, hence this. But the maximum wind that it flew in didn't go all the way to the maximum of what was available. Yeah?
With different data raster layers, environmental raster layers, say if you were using land cover, what would be the appropriate way to thin your data for something that is static?
So the
Like in terms of
spatial
resolution.
resolution. So that there you don't, I mean, it depends. Okay. Yeah, because there you need to think about the spatial resolution of the land cover and then see if you want to extract all the values for like your really high resolution tracking data where like a lot of points will fall on the same raster cell or not, and then maybe thin it based on the spatial resolution. Okay, so I guess we can take a break now for half an hour? Yeah?
Yeah.
Okay.
Uh-huh.
Cool. Thank you.